It's taking some time. Should be audible now.
See, these hilly, challenging terrains of our border areas are logistic nightmare. In these terrains, Indian Defence Forces employ 15,000 porters annually to carry supplies, but they do a limited trips in a year. When we ran calculation at BON V, we could be doing this with 3,000 vehicles in much less time. And that's 1,000% more efficient and carbon free. Now just apply these gains in disaster relief. We are losing audio again, Abhishek.
Satya, can you share instead?
Made to lead the global aerospace revolution. BON V is India's first AI-powered multi-utility electric air vehicle, clean, smart, sustainable, and importantly, safe. It is opening new possibilities for delivery and conducting autonomous mission in remote environments. Imagine aerial logistics 7 times cheaper than the current air transportation. BON V will make logistics super affordable at par with road-based mobility. The vehicle will be equipped with state-of-the-art technology to navigate itself during flight, avoid obstacles, and communicate with ground stations and worldwide through 4G, 5G connectivity.
RM001 can carry up to 200 kg to a distance of more than 40 km. You need not actively operate it once the destination location is entered. It automatically calculates the shortest aerial route and safe elevation to fly, taking into account the digital air maps. And it has the world's smallest and lightest avionics footprint. It's a beauty. Let's change the world one flight at a time.
BON V taking off.
Thank you, Via. That was quite an insightful video, and I hope our audiences found the video inspiring and were inspired by the work that BON V Aero is doing. So, moving ahead, now I'd like to also acquaint our audiences with the Aero-Modelling Club of IIT BHU Varanasi, which is the core organizing body behind Ascension TechNext 22. Our club is a team of aero-modeling enthusiasts which designs, builds, and automates various configurations of UAVs, multicopters, and hoverboards. In a nutshell, it is the best place in the institute to pursue your core interests in aerospace technology. Recently, Team Mendiza from our club secured the first runners-up position in the VTOL designing competition AL VTOLA organized by TechFest IIT Bombay. Apart from this, we also organize aero modeling competitions within our college and also take workshops to educate students about various technologies in the field of aerospace. Now, in today's webinar, you'll get introduced to the product lifecycle followed in developing any commercial fixed wing or hybrid UAVs at an industrial level. You'll also hear some great insights of the latest technology growing within the aerospace industry from our experts. Moving ahead, I would like to hand over to the Joint Secretary of our club, Abhishek Sheshnath Bhaiya, to invite and introduce the founders of BON V Aero to take over to proceed with the workshop. Over to you, Abhishek Bhaiya.
Yeah, good evening, sir, and good evening, all of you. I'm the joint secretary of Air Modeling Club, and we also have our acting secretary, uh, Gyanendra Singh. If he can open up the mic and speak few words.
Thank you, Abhishek. Hello, everyone. Hello, sir. I'm Gyanan Singh, Civil Part 3, the Acting Secretary for this Aero-Modelling Club.
So basically, we handle all of our club activities and the events that we organize every year and every month for our juniors. So moving ahead with the introduction. So in our meeting, we have Satya sir. He's the CEO and co-founder of BON V Aero. He graduated from BITS Pilani with a computer science engineering degree. He had a long experience in building drone solutions. He also comes from the leadership team of Asteria, the largest drone manufacturer in India, which is now a Reliance company. He had developed the world's smallest and lightest autopilot in the year 2015, and the size was of the autopilot was 40 millimeter cross 40 millimeters. So in our meeting, we also have Abhinash sir. He's the CTO and also the co-founder of BON V. He is an aero engineer, has mastered system engineering, had a decade-long experience into flight testing as well, having more than 10,000 hours of flight test experience. He is a certified test pilot by DGCA. Abhinash loves design new aircraft concepts and builds it in his workshop and test fly them on his own. So I would like to hand over to the founders and the co-founders to address this webinar on the product lifecycle that is actually followed in an industrial level of an unmanned aerial vehicle.
Thank you, Abhishek. Thank you, Gyanendra. Very nice to meet all of you, this young enthusiast, this young, energetic team of 36 attendees today. And love to be part of always that, academic community where the real, R&D or the real, the project level works, right? The concept level works happens there, happens at a place where students meet together and come up with an idea, and they slowly form a team, and the team starts building, uh, working on a project, and later that team can actually form a startup and can go on building a product. What an amazing thing, what a real, amazing thing for India. And the fact that you guys are actually building a aero modeling club which is helping many other students years and years together, where people are coming and students are getting to learn. So again, putting up competitions where if people from outside IIT VHU can come and participate. Very amazing. And I will take first 5 minutes, okay, to just talk about BON V a little bit, and then we will go with the design of fixed wing UAV. Okay, so I'm sharing my screen. Just let me know once you can see the screen on my presentation. Just
Yes,
any.
it is visible.
It's visible. Okay. See, would it be amazing to have a technology which can enable a safe flying future for everyone, right? So, introducing BON V technology, where we are aiming to bring air travel to streets in a smart, economic, and sustainable way through innovative design and development of electric vertical takeoff and landing vehicles, or simply we can call it as eVTOLs, right? An electric aircraft which can lift vertically and land in a very small 3 by 3 meter landing area, where actually you can design your garage even to house this type of vehicle. BON V's vision is to enable everyone to fly from their terrace safely through a smarter, carbon free aerial vehicle. We are the first company in India building a level 5 autonomous vehicle with a state of art intelligence, right, which will enable the end user to operate the vehicle from their fingertips. In order to achieve our vision, we are in a mission with strategic focus on aerial logistics sector for next few years. We would like to build this in the best technological, in the best technological company in smart mobility, and even the best electric aircraft in terms of operational performance and serviceability. We would like to build BON V, a great brand where intellectuals across the globe would love to work with us and contribute towards a better and greener future. How does our solution look like? Is this. We provide an end-to-end logistic solution to our end user. What do we mean by an end-to-end? Is there is a port infrastructure, there is the vehicle, there is fleet management software, there is piloting tool, and then there is a customer app, the end user who actually can book a parcel from one point to the other point and the vehicle delivers seamlessly, right? So everything that end to end is what we provide. And what we bring as a very, very new thing is basically the level 5 autonomy, right? Where today we see that the aircraft that we fly, the aircraft or these aircrafts that are flown, they are always piloted. There's a pilot inside. But drone has taught us that we do not essentially require a pilot on the vehicle. We can have it in the ground and can have the same ability, same functionality. We can travel from point A to point B. That is what is basically proved by drone technology, right? We are going one step ahead and saying that you do not need a single pilot for, you do not need, for each and every vehicle, you do not need a pilot to operate. You can have one pilot and one pilot can operate hundreds of vehicles. So the moment you start imagining that a single person is going to operate so many such vehicles, then autonomy comes into play, right? A great level of autonomy can actually make it happen, because at those times a single person, if he controls multiple aircrafts, it's basically he can only say take off, go to this point and come and land. He cannot do a lot of those minuscule control that we do today. We are vigilant on our drones when we are flying, and each and every command we generate from our mission control software or by a pilot, and we basically fly the UAV. That's not what we're talking about. We're taking it to the next step. Okay, so now coming back to the seminar today, it is about designing a fixed wing UAV. And today we are going to talk about the process that is followed in fourth generation aerospace and aerial mobility industries and at many startups. What do I mean by fourth generation? Is where we're talking about level 4, level 5 autonomy, where we're talking about electronics takes the majority of or contributes the maximum of an aircraft or in the vehicle, whereas 70% of your cost or 70% of your critical component are going to be electronics or electromechanical parts, and mechanical is going to be less. So that's the we're talking about fourth generation or vehicles here. So Avinash will take you through the overall process of what is followed in the industry during the design development, and then what I will do it followed by after Avinash finishes, then I will take you through the R&D or specific design process which is followed during the R&D phase. I stop my screen here and I may ask Avinash to go ahead and share his screen and present to the audience. Thank you.
Yeah. Thank you, Satya. Thank you very much. Am I audible? Can any one of you confirm me?
Yes, sir. You are audible.
That's great. Okay. Uh, Good evening, everyone. I can see close to 40 students are here. So I'm feeling very excited here. Like when I remember my days back then, 2012, 2013, I was the only person in my college, only student I would say in my college who was working on drone. And maybe many of our professors, they didn't know what is drone, all this thing. But I can see like even a couple of colleges. This is the first time I'm giving in IIT VHU this presentation, but I visited IIC Bangalore. There are a couple of other VIT Meshra, those universities, those colleges, and I can see on an average, I can see 100, more than 150 to 100 people there working in this technology. So that's where I'm very excited, like how this emerging technology is growing in the country, and people are getting their own interest into it. That's really great, all of you working on this. Okay, so we'll come to the topic today. Basically, yes, I mean, even when I was a student, I was also very excited. Anything I used to see, I used to think about flying that thing. Like there is a advertising board, printed and placed in an electric pole. Then I'll think that, and I will think, yeah, ये तो थोड़ा strong है. Then let's get it and let's fly this ना. ऐसे कैसे उड़ता है देखते हैं. Then I used to get that and build some wing and all this thing, and I used to fly that. Many things like we have tried. You must be knowing the Peter Ripple, and he's a very mad guy to fly anything. He sees his shoes and he is to try to fly his shoes. He tries to fly his chair, table, anything he sees. So that's very excitement comes into mind when we are, during those time.
Yes,
So
sir. Pretty much same is in our case as well. The speed
yeah,
spiral and the flight test videos we kind of share to all of our aero modeling enthusiasts to get
yeah,
into
yeah.
the insights of the fabrication.
Yeah, this brings a good amount of excitement. Something we see and we think of flying that. Let's take it to airborne huh? and fly it. But yeah, so what happens is, of course, yes, we do fly, but end of the day, what we really look for, keep build something which can be come into some which can fulfill some purpose in the society. Maybe yes, we are doing for fun, but something should come out of it, and it can fulfill some purpose in the society. It can come, it can help to many of the department to fulfill their fulfill their demand. And as well as there are many gaps are there, technology gaps are there in many departments. I'll just give you a very small example. Like if you see in those hilly terrain areas, like where the snowfall comes, like after June or sorry, I mean after September till June, there will be snowfalls in the hilly terrain area. For an example, Ladakh and Leh. And just imagine there are people are staying in those hilly terrains. Even the Indian Army, they have base camps, they have battalion divisions. Those are there in those high altitude area. And when the roads are blocked because of the winter and snowfall, now you just imagine how they can get the essential supplies. How if someone health condition goes bad, how can we bring them to a local hospital? I mean, those these are there are many challenges, not only in a heavy lift side, but if you see there are any medicine requirement is there. If it's in Himachal Pradesh, those type of state, Uttarakhand, Himachal Pradesh, those there are many places are there. Like I was riding once in Nepal. Okay, from I crossed almost 4 states in Nepal, and I was thinking like the people they're staying in the peak of the hilltop, and from the root of the hilltop to the peak, it is just the air distance is 500 meter, wherein the ground distance is almost more than 5 kilometers, I would say. You have to just turn around the hill and come to a peak of the hill. So that is very challenging, what I felt, wherein we should we badly need something this type of technologies. Maybe a small drone, maybe a small VTOL, fixed wing or multi-rotor, or if it is a heavy payload, we can go for a eVTOL, and then we can supply those essentials. So why I'm talking about this is, when we build something, we build till a prototype stage. But when the moment when we think of flying this vehicle in a market in a for a particular specific application, it will go to a customer and those things. So in that case, we need to be more vigilant to the vehicle. How can we make this vehicle more reliable? How can we make this vehicle more cost effective? And then how can people gain faith on our vehicle, whether this vehicle can fly? Because I mean, most of us should have experience like anything. When we get excited to fly anything, we could fly and we could crash as well, right? So that there are many, I would say, variables are there wherein it ends off in a crash. But that is not something which is getting which will be accepted when we bring something into the society. So that is why industrial grade process flow is very much required for us to follow, wherein we can ensure that the vehicle is reliable, the vehicle is safe enough to operate over the crowd. Just imagine you are flying a drone over a urban area and something goes wrong, it crashes into urban area. That's a huge risk that we will be taking. So for that, those things, it will be very much essential or required for us to understand what are the industrial approach, industrial process that we follow to build this type of aerial vehicles. So since these are the aerial vehicles, the risks are really at a very higher level. So we need to be more, we should follow the process in a very proper way. There should be any mistake will be accepted in this industry. So I will take you through a very basic flow chart for a new product development. For example, we are thinking to build a very new kind of fixed wing or UAV or VTOL or any multi-rotor. Is very standard in nature, but yes, but it will show you a standard process that we'll be going to follow to develop that. So this process flow will explain from the very beginning when we are thinking of building a new product till the end, wherein we'll be supplying the product to our customer at a scaled quantity, that is called the production. So from this point to reach that production level, what a process we an industry 4.0 and then onwards that we follow in aviation standard to deliver those output. So this is very interesting. Let me just share my screen, and someone of you maybe just confirm me if it is visible or not. Uh, okay. Can anyone confirm me whether my screen is
Yes, sir,
visible?
it's visible.
Awesome. Okay, so this flowchart, it gives a very standard process that the industry follows to bring the a very new concept to the product. This flowchart describes about the detailed process flow of a new product, that is called end-to-end product development and its life cycle. The very first thing in a new product development is capturing customer requirement. Here the CRM, that is called customer relationship management, and the PLM, that is called product lifecycle management team. These two teams are solely responsible for capturing the customer requirement. So this is well understood to everyone, right? So before we build something, we should have a requirement in place. If there is no vision, no requirement, we then we will be confused what we will build. Okay. So this requirement should be in place, and wherein the CRM and PLM team will play a very major role in this to drive the requirement from the customer. Then what we do, we usually analyze whether the product requirement that we got from the customer, whether this product is a very new product or not. So if this product is not new, that means this product exists in some or other country or with some or other vendor or supplier. Okay, then we need to identify that supplier. So in this case, what will happen? The SCM team, which is called supply chain management, they usually are responsible for the procurement and the sorry, is there some noise coming?
Apologies for that disturbance, sir. Someone's mic
Okay.
switched on. Yeah,
Okay.
you can proceed, sir.
You may mute your mic if you're not talking. It is good. Okay, I'll continue. Okay, so supply chain management is describing they're responsible for procurement and the relationship with the suppliers. So what will happen is if this product is not new, that means it is available with some or other vendor or supplier. Then what we'll do is our SCM team, the supply chain management team, will identify the correct supplier who can supply this product. Now we'll come to yes, wherein the product is new now. Okay, so that means this product does not exist maybe in the country or in the globe anywhere. Okay, then the organization needs to go for a new product development. So here the CFT team will start the conceptual design. So the CFT team stands for cross-functional team. This will include your different type of R&D team, your flight test team, your product design team, your software development team, okay, your avionics team, okay, your aerodynamics team. These all are like part of R&D team that in a quality standard we call as cross-functional team. Then once the then if the product is new, then the cross-functional team will start the conceptual design. Okay, so you can see it here that we'll go for the conceptual design, and this again will go for the review. Once the conceptual design is in place, it will go for a review, and that review will be done by the cross-functional team, including the PLM team, which is PLM and CRM team who have derived the requirement. They will again come and review it whether your conceptual design and whatever the theory. Basically, this is in a theory level that you must have done. I mean, everything I have spoke to Abhishek. He has also worked on this. They have derived some conceptual, mathematical model. So this is what the phrase will describe. So here you will have theoretical basis. There different type of designs, your conceptual model, your analysis report. Those things will be there in paper. So that will first get reviewed by the CFT team and your customer relationship management team and product lifecycle team. Then what will happen is once this review is done, it will go for a supplier identification by SCM and design. So what will happen is in this review process, so what will happen once the our conceptual design is reviewed, we'll have a proper plan what we are going to build. Okay, in the conceptual, you in a conceptual design, you must have gone through a thread of study of different type of air vehicles. You might have gone through fixed wing, you can go through multi-rotor, then you can go through VTOL. What is more feasible for the customer, whatever they have asked for the requirement, then we can finalize the one particular configuration. We can work on the aerodynamic study for that vehicle. Then and at the end of the that activity, what we'll get is we'll get a blueprint of our design and the bill of materials, what all equipment that are going to be used in that design, that we'll get to know. So that equipments will come under bill of materials. So in this bill of material, that will be given to the supplier. So SCM team, the supply chain management team. So what supply chain management team will do is it will look for the supplier for those equipments. Okay. Then you will go to next flow, whether when we identify the supplier, then we go for whether the supplier is new or the supplier is old. So the supplier old means we already have the supplier from whom we have got the same part before, and we don't need to again ask for any evaluation with the supplier because we know them before. We have done any transaction before. So if the supplier is not new, we can directly share our design and our bill of material with the supplier, whatever we require. Then we will go for further evaluation. But if the supplier is new, then we are identifying a very new supplier. We have never spoke to them. Then we will go for a supplier evaluation. Why the supplier evaluation is required? Because in
Avinash,
industry, we
Avinash, if I may interrupt with your permission,
yeah.
and if is there a way that we can highlight or draw when we are going block by block,
Okay.
so we can put one
Okay.
one
I'll have
line?
a highlighter. Is this fine?
This should do. It's good.
Okay. 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 So we are at this stage now, the supplier, And what we are talking about is we have now a new supplier that we are going to talk further design and this thing. Yeah, why what I was talking about is why we need a supplier evaluation. So the moment when I say supplier evaluation, as part of an industry standard, we cannot believe anyone in the vendor list who can give us the material. So for an example, I need a propeller. I cannot just go to a market and get the propeller. I don't know how this propeller was built, whether this propeller can withstand with the requirement I have. Let's say I'm flying in a different let's say you are flying in a different high altitude, or you're flying in a different environment, like for you, like you're flying in a Martian environment, whether that propeller will withstand that particular disk loading or those things. We don't know that, right? So for that, the supplier evaluation is very much required, wherein the supplier has to meet our assessment. Means we should the component that we're going to procure from that supplier, we should have a requirement for that for that part. So that part, whether it meets our requirement or not, that we need to evaluate from the supplier. So in this case, we would require the supplier assessment format and audit report. So basically, what type of process our supplier follows, what type of quality standard our supplier is meeting to make that particular component, what type of quality control they are following, what type of process they are following to meet this. This all will be very much required for us to understand before procuring the material. If this supplier doesn't meet the assessment, then of course we'll reject the supplier. Again, it will go for the new supplier identification by SMN design, and it will again come to the same loop. Now, if it is if it matches the meets the assessment, the requirement that we had, then it will go for the supplier registration. So we'll register the supplier. So this will help us in tracking our supplier in future aspect. So this will come like when we say this is known, that means we have already registered the supplier some time back. So this is where we keep a record of our supplier who is providing which component. So we'll go for the supplier registration, and in this case, there will be a non-disclosure agreement will be signed with the supplier. That means when you are sharing any component to procure, maybe you might be sharing your design to be procured from this, to be manufactured by the supplier and given. So that means you are providing your intellectual, design and drawing to the supplier. So that means you have to sign a non-disclosure agreement. So that those things, and by supported by it will be the supplier will be submitting the supportive reports like audit report, those control plan process, all these things will happen during the registration process. Then it will come to the same part, like I explained, right? The supplier then will share the design to the supplier. I'll come down. Once the design is shared with the supplier, then this design will be reviewed by the supplier to confirm the feasibility. So the supplier basically will take our requirement. Supplier will take our, in case of any component, it will take all the spec that we need. If in case of in design, then supplier will look for the design, review the design, and supplier will confirm from his end that this component is available in us, or this the design can be manufactured in our facility. Once this okay, then it comes as the action item is it feasible by the supplier. Now supplier come back to us and is saying ki, okay, it is feasible or not. Let's go to no, it is not feasible. For an example, if this the design we have shared with the supplier is not feasible, then this design needs to be reviewed by the designer or supplier. So there will be two-way communication will happen from our team. So from our organization, our designer will be talking to the supplier, and the supplier also will be review the design, whether they can change some process and make it happen, or our design team will look for whether we can modify the design which our supplier can do the job. So this is called loop stage 2. So I'll explain you while I'm talking this loop stage 2. So this is basically the backflow of the process. Okay, so there are many stages wherein it will again go for a backflow. So that will again come to the initial flow diagram. So it will go to the LS2 stage. So just remember this LS Loop stage 2 is the design to be reviewed by the designer or supplier. Once it is reviewed, then what will happen is then we look for change in design or drawing. Okay, if it requires any change in design on drawing, again we go for the new supplier. If the same supplier can do the job, then we can mention as the supplier is old, then we can go for no, then we'll again supply the share the new design with the supplier, and again the supplier will review our new design, and again we'll say whether it's feasible or not. Now we'll come to the yes clause. That means the design that we have shared with the supplier, that is feasible to be manufactured. Okay, so then we'll come for the procurement and inward test. This procurement means we'll procure a sample. It is not like we need, let's say, 10 propellers and we'll directly go for 10 propeller. No, we'll go for one single propeller for a sample. This quantity might vary with respect to the cost and the requirement. So basically the minimal number of quantity that we call a sample, that we procure from the supplier in the first stage, and that will go for the inward test. So when we procure the sample, with the sample procurement, we also will require the FAI report. That's the first article inspection report, which will include the inspection report, the process flow chart, the control plan for that particular sample, what they have followed, what type of quality standard they have followed to build that particular sample. So once this all the supporting and as well, supplier might provide you the manual also in case of some other equipment for GPS or for flight controller. When you procure it, you usually get a manual also. Supplier can provide those things. So that is called your primary manual. I'll come to this part. So once this procurement is done of the sample component, then it will go for an inward test. So during this inward test, our cross-functional team, that is called R&D team, will provide the required test type. What type of test we need to do with this particular component? What type of test method we have to follow? What is the routine routine drawing, the assembly instruction? If it is a mechanical component, how can we assemble to a bench and test the sample whether it is matching the spec that supplier has provided or not? That our cross functional team will provide. And also there will be primary and secondary manual. So this primary manual is what supplier has provided the manual, and the secondary manual is what our cross functional team has generated to test that particular equipment. So basically this will be a bench test wherein we'll be testing on ground. It is directly not going to air vehicle and we are flying that vehicle. It is not like that. Let's say for an example, we are getting a propeller, or we are getting a very our first frame design getting manufactured from a supplier. Then we'll test whether that frame is able to carry the load that we have, the requirement we had. For an example, we are building a fixed wing for 10 kg all of weight, whether our the frame that we are, the wing, let's say we are manufactured, we got it from supplier, whether that wing is capable of carrying the 10 kg of load or not, or the propeller, whether it is capable of giving that type of thrust or not. Those there are a couple of ground tests. Those test plan and those things will be prepared by our cross-functional team, and this will go for an inward test. Now the inward test is passed or not. The inward test is passed. If it doesn't pass the inward test, that means there is some non-conformance. That means it is not meeting our requirement. It has failed the inward test. So what will happen? Again, it will go to the LS2 stage. Then again, the design needs to be reviewed by the designer or supplier. Of course, we'll talk to the supplier ki whatever we have given the requirement, it could not match our inward test. Our designer, supplier, both will work with each other, and they will work on that where it went wrong and all this thing. Then it will go for again the LS1. It will backflow to the flow chart. Now we'll go to the other case wherein the inward test is passed. Now whatever component we have got, it is tested and it is passed. Then it will go to the R&D integration of prototype. Now what will happen is, now we'll build the prototype. So there are many components will come through this cycle, and at this stage we'll have our all the bill of materials ready and inward test will be passed. Then we'll put all the bill of materials together and we'll build our first prototype, R&D prototype. So when we build this prototype, we know that after the prototype build activity is completed, it will go for the testing, right? So for testing, while we are building the prototype, again our cross-functional team will provide the test plan for the prototype. Likewise, the cross-functional team has provided the test plan for the invert test. Again, the same thing will happen, but for the prototype testing, our fully integrated prototype testing. So there are again the same type of test types, test method, routine drawing, assembly instruction, like how we'll integrate this prototype. All this thing will come here, and then the team will follow that process and they will integrate the prototype. Okay, now we'll come to the prototype test. So once the prototype integration is done, it will come to the prototype test and approval by design, R&D, and PLM. So when we will be flying this first prototype, there will be again we'll be testing. We have the requirement in place from this stage, right? Product review by PLM and design. From this stage, we have the requirement ready. So what we'll do is we will fly the vehicle and we will look for each and every specification and requirement that we have defined before, whether they are meeting that requirement or not. Now the question comes is the prototype okay as per the drawing and requirement? From this flight testing, we'll come to know whether this prototype is meeting the requirement or not. Let's go for a no cause. Okay, now it is not meeting the requirement. So if it is not meeting the requirement, anything going wrong, how can we identify that? So for that, there is a process called RCA and CAPA, CAPA. This RCA stands for root cause analysis. So, okay. So anything, any issue occurs during our testing, that means some or other component is getting failed. Why it is getting failed? Okay. So there is a five method. Okay, 5W method is there to come out of a root cause for an any non-conformance or issue. That 5W is called 5Y. So for example, your system crashed, it went into stall and it crashed. Okay, now why it went into a stall? Then we can mention okay, there are some CG imbalance, so it went to a very nose was the tail was very heavy, so it went to a high angle of attack. Okay, then why it went to a high angle of attack? Because there was a CG imbalance. Then we came to know okay, the CG imbalance was the root cause for the stall. So similarly, there will be why. Behind every why, there should be a clause, there should be a reason which will derive us to a root cause, where it went wrong exactly. Okay, and because of that, there are many things happened in stage by stage, and the incident occurred likewise. Then once this root cause analysis is done, we found the root cause. We will decide how to the root cause, that issue that we have identified. For that, the CAPA will play a role, the kappa that we call. Kappa stands for corrective action and preventive action. Once this root cause is defined, then what corrective action can be taken for that
So you are not audible.
Let me check with Avinash. He's not audible.
I think sir has lost his connection.
Abhinash is trying to rejoin. Due to some small internet glitch, he is dropped out. He's trying to rejoin.
No issue, sir. Meanwhile, if anyone of you has any doubts in this framework, you can directly ask to sir or write in the chat box.
Will they teach us to how to design also?
So this seminar, Jeet, is not the scope is not to basically teach the design part. That will be a very different seminar. Okay, where and it is again a design part is not going to be one. It will be series of right events that we can plan in the future.
Yeah, Satya, sorry. I don't know. So for some reason, my internet went off and I was not able to reconnect. But yeah, I am back now.
We can hear you loud and clear.
Okay, okay, all right. Sorry for the inconvenience. Okay, I'm not able to share my screen. Organizer, Abhishek, can you allow me?
Yeah, let me make you a presenter, sir. Just a minute. So you are now a presenter. You can share your screen.
All right. Yeah. This correct me if I'm wrong. I was just in root cause analysis, right?
Yes, sir. Yes, sir.
Okay, okay. So yeah, so once this root cause analysis is done, then we'll work for the corrective action and preventive action. What kind of corrective action, preventive action we can carry to mitigate those issues that we have faced during testing. Then what will happen? It will go for the LS3 loop stage 3, wherein it will ask for if any major design changes is required or any design revision is required or not for this corrective action and preventive action. If the major design change is not required, that means we might have done some silly mistake while our prototype integration, maybe some small process improvement we need to do. In those cases, we can go for again reintegration of the prototype, wherein we can we can optimize our type of the test method or assembly instruction, those things, and we can again go for the testing. If there is a major design change required, then it will again go to the loop stage 2, wherein again it will be reviewed, the design will be reviewed, and it will go for the change in design and drawing, and it will again go for the supplier, and it will come through the same process. Now we'll go to the other clause wherein the prototype is tested and it is okay as per the requirement. If this prototype is tested and okay and it meets all the requirement, then what we'll do is we'll send the prototype to the customer for approval. So this will be executed in form of trial or demonstration. What happened is we used to carry one or two prototype to the customer location, and we show them flying the vehicle. We show them the performance. Okay, this is meeting the performance whatever the customer has requirement. They had. So that activity will happen here. Then there will be another question will come is whether the prototype is approved by the customer. So once we show the demonstration to the customer, whether customer is satisfied with this or not. If customer is not satisfied with this, that means there is some or other issue or non-conformance is exist in the system. That should again go for a root cause analysis, where why is customer is not satisfied, for this reason customer is not satisfied, why this issue is coming. Then for that this will go for again 5 why method, and we'll get to know the root cause analysis, and again it will go for the kappa, and kappa will call for the design, the required design revision is not or not. Then it go for the review and those things, ls2 and ls1. Now we'll go for the best case, wherein our prototype is approved by the customer. That means our prototype has matched all the requirements the customer has asked for. Now, what will happen is once this prototype is approved by the customer, that means we are almost at the stage wherein our product is reliable, safe, and our customer are liking our product. So now what will happen is whatever process that we have defined here, it might have gone through kappa and process might have gone through some changes. All this thing must have happened. The assembly instruction might have gone through many revisions to prove the prototype reliability, those things. So we will have a final drawing of the finished good. I would say here this FG stands for finished good. That means it's a finished product. So this final routine drawing, assembly instruction, the final bill of materials, maybe you might change five, six different type of GPS, five, six different type of propellers during your prototype testing to match the requirement. So this bomb will, the bomb I said here, this will go for many different type of component to validate. But when we come to this phase, we'll have a specific, I mean, the particular bomb ready for the product. So all this final process, final drawing, assembly instruction will come into this phase. And what will happen is we will then manufacture some limited series of production. We'll do a limited series production means previously we might have built one or two prototype, but here we will build at least that we usually follow five fixed wing or five aerial vehicle in our unmanned aerial vehicle standard or aviation standard in electric aviation. So for minimum is what, five, we can go more, but five vehicle is what we usually plan for pilot run, or 5 to 10 vehicle I would say we used to manufacture. So following this process, once this limited series production, what we call as LSP, limited series production, we manufacture, again we'll send this for to customer for pilot run. So previously we have sent, we have sold one or two vehicle to the customer, to the client. But now what will happen is we'll provide multiple vehicles, multiple multiple, I would say, fixed wing or any drone. Multiple drones will provide to different type of clients. Also we can provide. It's not only one client. We can provide five different clients, five different vehicles, wherein they can run at different environmental condition, and they can check our vehicle where it's running good or not, it is reliable or not. Then when we run the pilot lot, then another question will come whether this pilot lot is okay or not, whether all the system that we have built, whether they're flying good or not, they are satisfying our performance or not. This thing will happen. If this doesn't satisfy, again it will go for the root cause analysis and kappa, and followed by the LS3, LS2, LS1 process. But in best case, if the pilot lot is okay, then that means it is completely satisfying the requirement of our client, and it is safe and reliable. Then we'll go for the production lot, where we do a mass manufacturing of the drone. And then we can this then I mean बेचने वाले का काम है, they will sell the product. But yeah, that the process ends here. So I believe it was clear for everyone to understand. But of course, if anyone has any doubt, can ask me, and I'd love to answer them.
We'll take the questions at the end, and
Okay.
Avinash, I will next go ahead with the R&D process. Okay.
Sure. Okay. Let me stop my screen sharing. You please share. Okay. It's stopped, right?
Yes, sir.
Oh, all right. Okay. Satya, over to you.
Thank you. Just someone acknowledge once you share the presentation.
Yes,
It's visible, sir.
Okay. So now I'm going to talk about the R&D process flow. Okay. And again, I'm going to touch upon very high level process flow that is followed in the design phase. If you would have actually carefully seen the block diagrams that the flowchart Avinash was presenting, at the at the third block, it was written that the requirements are going to be discussed with the R&D team, and once the R&D team finishes the work, they will come back and talk to the customer relationship management team, right? So that is where this R&D process flow comes into action. What are the objective? A long-term objective for R&D team is to design creative products with effectiveness and efficiency. How do we define creative? Is it is cost effective, it is reliable, it is engineered, it is aesthetic, it is timely delivered, it is very innovative, the product is versatile, and it is ergonomic. These are the key elements that goes as an objective when we are designing an R&D product. The first stage we go is an input stage. Like the customer relationship management team brings out the requirement, and those requirements are called as the high level type of requirement, which is what actually you see in the competition also. Today, the Maze challenge, what it has basically written about the wings on Mars is a high level, problem statement, high level requirement is written. Now, the engineering team of various departments need to actually, draft a design requirement document called DRD, and that requirement document is a bit detailed document which is derived from the high level requirement. Okay, or like let's say in our case here, you can consider the problem statement given by the mm, the maze for the maze challenge by uh, by the
Tech,
committee, by the
tech next, tech
the
next
techniques.
2022.
Okay, by the Technex 22 committee is the high level. Okay, is the requirement. Okay, high level requirement. Now after DRD, you go for a review, and in industry basically we follow this review of DRD, and what is the outcome of that is an DRD gets released to everybody to basically follow to the next step. Next step is the concept design stage, or we say it conceptual design. In conceptual design, say that you are developing a fixed wing UAV. It can be a flying wing, it can be a high wing or low wing with a H tail or a T tail, V tail, right? Those can be different concept and the configuration that you can come up with, and each of them would have their own pros and cons. In industries, we generally allow 5 concepts to go with. It can be more agile, but the more concepts you allow, more confusions and those that you actually create. So after the concepts are you work on the concept. Even during the concepts also you do mm, you go through paper, you go through published papers, research journals, take out the data, understand that. Then you look at implementation, somebody has implemented, you look at those practical data, you go for conceptual design study, more of conceptual design study, and you prepare a report, and then it goes for a review. Okay, and in the review you basically involve many people within the industry, which is your system engineering, your design, your avionics, your manufacturing, your hardware software team, right? All of them. That internally it may so happen that in a very small setup, in a group like setup where 3 to 4 people are participating, one might be doing 2 or 3 functions. Somebody may do system engineering design, and some may do avionics, hardware software, and even general computer software. Somebody would be doing manufacturing of that part. So in a 3 people kind of structure, but it is important for you to know that you are playing that role. Okay, and what's the outcome is a report which comes up. Then you go to preliminary design. In the preliminary design, what we do is we do not take all the concepts, even though there is novelty involved and each concept looks very great, but we take minimum 1, maximum 2, and do a feasibility study, and then and there select only one concept which will go for preliminary design. And the preliminary design goes with a unit level prototyping option. So sometimes, a design can be realized if you do some level of prototyping, and for prototyping, you need certain things to prototype. Okay, those documents also you require to prepare. or you can physically even buy and prepare a document along the side, also buy and get the prototyping parts unit level. Mm, you can say it kit, you can say it module, you can say it subsystem, whatever you have to call it, but it should be unit level. Okay, at unit it. Then you prepare a preliminary design review, you conduct a review, and then a PDR is prepared, a report is right prepared. And after the report is drafted, then you move to, so that's the outcome of preliminary design. Then you move to a design stage called detailed design. And in the detailed design, you go for a detailed design review. What is the difference between a preliminary design and the detailed design? It's in the preliminary design, you have just come out of the concept, you have selected a concept, and then you have done unit level. But in the detailed design, you start putting them together. Okay, what you have done in at a very discrete ways, that you start putting them together, and you do a you look at the integration aspect. You look at, okay, if mm, I have you know delta wing, does my autopilot code is fully supporting the delta wing? Because in a delta wing you will not have a vertical stabilizer, horizontal stabilizer, right? It is just the you need to embed all that into the delta wing itself. So that you may have done the coding, but that integration and putting together and doing that simulation level testing is even preferred in detailed design. Sometimes if you have the practical prototype, you can do that also in the detailed design. Then you prepare a report, and the report goes under basically if there is any changes where the in detailed design you spend so much of time in an iterative basically changes. So you do prototyping, then you go to actually Avinash, what Avinash was explaining, try to recall that flowchart. In that you basically go for prototyping, and from prototyping, if there are any changes, you come back and do stay in the detailed design. So after, when we get into the detailed design, at the stage of maybe the initial detailed design, we go for prototyping, and we basically get involved with the R&D team, gets involved with every other team which Avinash was explaining, and then you know develop develop the product. Okay, yeah, this is in brief about it. Thank you. Any questions we can address?
Yeah. Mr. Zahir Sarkar has raised his hand. I think.
Participants, if you have any questions, you can put in the chat box, or you can unmute your mic and ask.
Okay, so another thing that I want to say is the purpose that BON V is sponsoring Mage and Wings on Mars event is not just because we want to support student communities and clubs, right? But it is much beyond that. We want to understand who are those champions among all the students who are going to participate in this competition, who has that higher potential to work for industry even when you are pursuing your academic, right? And once we identify them, okay, we identify those students, we are going to give them opportunity to work on industry identified challenges in a company environment, and with lot of benefit that actually can come along. So we are going to go through every proposal independently and evaluate who are those champions, and we are going to be very vigilant on the 1 month long process next, which is happening. And uh, we will circulate those students' name to many other companies as well. The moment we select some students that we believe that they have higher potential. They can come and work in the company environment, even when they are at academics. Okay, we will circulate them to many other companies, our allied partners, for consideration. So you have next 1 month to write your proposal. Okay, don't waste your time. Don't try to look at various different proposals, and try to be unique. Try to write your own proposal, think through, give a really good thought, put your good energy, good time doing this, devote your good time. Okay, and give your best. And here industry experts are watching you, and we want to pick the best minds for a new opportunity. Okay, thank you.
I think that was kind of surprise to us because that we were not knowing such kind of initiative will be taken at the end of the workshop. Uh, I would really like to thank BON V for collaborating with us with such an exciting and informative webinar. We believe that such kind of initiative will give the needed motivation to our participants and juniors to move ahead in this exciting field. And we kind of learned a lot of new frameworks that is being employed in the design procedure of a UAV at an industrial level. Lot of learnings, and we hope that our participants enjoyed this webinar. Team Indiza and Gyanendra, if we like to put in some words for the conclusion. I think Gyanendra is away from keyboard. Srikar?
Yes, we are.
Yeah.
So I'd like to thank everyone for attending the webinar, and especially founders from Bonvi, Satyavi and
Avinash sir.
Aditya. Thank you, everyone. And we hope that you all the participants, work hard on the problem statement of needs. And yeah, that's it. We are looking forward to seeing your unique and innovative solution. Thank you.
Yeah, thank you so much, sir.
Thank you, Abhishek.
Okay.
Thank you
Thank
very much.
you. Thank you, everyone. Good night. Bye bye.
Signing off.
Thank you. Thank you, sir. Thank you so much.